careful when doing energy system analysis. Here are some pitfalls. First, be careful when using units, but mention them as often as you can. Units for power have a very different meaning than units for energy. And for instance, if you compare 1 megawatt with 1 megawatt hour, do you know how to calculate between those two and what those calculations mean? You should know if you do energy system analysis. And if storage is within the scope of your research, it becomes more complicated because then units connected to storage might mean slightly different things, like the speed with which you fill or empty a storage, or the capacity of that storage. That capacity of storage could, for instance, be in kilowatt hours, which is then again an energy unit. Get trained to recognize large units, for instance by knowing some of the larger statistics, such as the electricity demand for the Netherlands, which is roughly 120 terawatt hours per year. And also don't forget to add time or time specificity where that is possible. Energy. How do you see energy? Do you use the term energy at all? Be careful. If you try to say electricity, it is better to say electricity, because there are so many more energy flows and so much more energy than only electricity. So in the Netherlands, for instance, electricity is only 20% or so of the energy flows. And that also depends on how you look at it. Do you look at it from the demand side? And do you connect KPIs to the demand side, or more from the supply side? And how about time here? Do you talk about one moment in time or during a certain period, such as a year? Policies, for instance, often are specific to one of these sides. They're either specific to a certain carrier, but they can also be specific about demand. For instance, are our renewables policies specified in terms of demand or in terms of supply? Do you know? And shouldn't you find out if you don't? I mentioned it also already 2 times, but time is super important. Can you actually make averages, for instance, if you want to present results? And what do you average over? This can be problematic if averages do not represent very well the dynamics of that duration that you're trying to average. Think of scope. What is your time scope? Is that a particular year now, a particular time period? Is it a long trajectory? Is it some moment in the future? And connecting to that, what is your resolution of your analysis of the logic of your energy system analysis? Is that hourly, quarterly, monthly, yearly? Is it decades? How about the dynamics in between? Are you considering pathways towards a certain future, or are you making a snapshot? This all affects very much what your results imply. And it's very good not to mess up differences between kind of different energy system analyses. And also, if you try to understand other people's work, it's super important to know what assumptions do they make about pathways if they describe some snapshot, some end result. And the reverse, if they discuss something now, what does that say about something in the future, in the further future? And finally, a point about system boundary. So for energy system analysis, the boundaries are fluid. More and more carriers get integrated, more and more systems get integrated. And although you need to scope down and be clear about your scope, that doesn't mean that the rest of the world doesn't exist anymore. I'd also urge you not to focus on too few KPIs, because they might be out of balance for the analysis that you're trying to do. If you find good advantages or a good KPIs where your energy system that you're trying to analyze scores well, there are bound to be other KPIs that are very relevant and important that gives you a better view of the disadvantages of that energy system. The question is also how specific you are to a particular case, a particular real-world system. And sometimes this feels a bit like a paradox where you want to say something general with your analysis, but you only have data about some specific case or cases. And I think the paradox is that typically I see when you go very case specific and detailed, you might uncover these kind of general patterns, and you might be able to find them only by going very specifically into the cases. So don't shy away from case specificity, also if you're after more general patterns. And be aware there's always more. If you focus on a particular system, there's also the consumers and how they behave. If you focus on consumers, there's also production. Where does the energy come from? If you focus on electricity, there's also heat. If you focus on heat, where does the heat come from? If you focus on hydrogen, where does the hydrogen come from? If you focus on CO2, what are other environmental effects? And so on, and so on. Be aware that there is always more, and that also other things are relevant. That should not stop you to focus, but you should be open to discuss the fluidity of your system boundaries. And try to be creative and sharp in what it means within your system that you have analyzed in your energy system analysis, but also beyond. And basically, this all boils down to how do you make this analysis fit for purpose? And for that, you need to know what you try to evaluate, and in what terms you evaluate that, and what are reasonable assumptions to do this. Okay, these were some pitfalls for energy system analysis. Good luck.